Okay, our next thing we're going to look at is beyond slope-intercept point slope form. Point slope form. That's what I believe the thing is called, the assignment. And now, really quickly before we go and do the actual problems, I want you to understand kind of what point slope form is about. So we've done two things so far. You have your graph, maybe you know where the starting point is and how fast it goes up or down. You can graph a line from that using slope and intercept. That would be slope-intercept form. However, maybe you don't know how fast it goes up or down. You know that, oh, I don't know, I start out owing $500 and it'll take me 10 weeks to pay it off, and then I'll be at zero. And then you have a situation that looks like this. I don't know how steep it is. I can figure that out, but I can also just use the two intercepts to graph that. That's called standard form. And finally, if I know how steep it is, but I don't know where it crosses either of these. See, I know this point right here and that point right there, and I want to graph up a line that goes through those points. Well, I can figure out how steep it is from the 2 points, and then I can use point slope form if I know either of these points and how steep the line is. That's what point slope form is. It's basically built off of slope. I'm going to tell you a quick rundown of how we came up with point slope form. First, we knew that, and this is something I've typed in many an assignment, m slope always change in x, or sorry, change in y divided by change in x. So another way we could think about that, actually, m is slope, just to be absolutely clear. And then if I go down to the next line really fast, I'm going to zoom in some more because the power of computers. Here's what happens. So we have our change in y, how much y changes and how much x changes, and we turn into a fraction for slope. What does that look like? Well, I'm going to make this do 1. So I have my change in y divided by my change in x. That always gives me slope. Now, one thing you may want to know, how do I find how much x changes and y changes if I have points like a, actually I'll type this one, or if I have the point a is 3, 2, and b is, I know, 17, negative 5, negative 5. All right. So how much does x change and how much does y change? That's what we're asking ourselves. Well, I can figure this out mathematically. I'm going to make this go down a little bit so we can actually see. Okay. All right. Half the battle, isn't it? Okay. So here's what I can do. I'm going to figure how much x changes and how much y changes. I can use a little math. Okay. We'll figure that class, right? So notice that. Just want that to be black. No, I want this to be another color. I can notice that from 3 to 17, x changes by, well, it goes up 14. Plus. X goes up by 14. And then if I have 2 and negative 5, well, I find out that that goes down by 7, right? And I can say what y is. So I end up with negative 7 over 14, which is negative 0.5 or negative 1/2. That's my slope. However, this is what are we doing to find 14? Well, really, this is just 17 This is just 17. Oops, that's on the bottom of the fraction. 17 minus 3 is how I got 14. It's a very important thing to understand is we subtract to find how far apart numbers are. So when we're finding slope, when we're finding how far apart 3 is from 17, we're really just subtracting to find that. 17 minus 3. And when I ask myself, how far is it down from 2 down to negative 5, I did 5 minus 2, or negative 5. And I subtracted 2 from that, and I got negative 7. So this right here is what we call the slope formula. Why is it a formula? Well, you don't have to think to do this one. You just have to follow the instructions, and that's what formulas generally are good for. They're instructions so that I can solve something. I end up with slope equals I2 minus y. Do that again. Y2 minus y1 divided by x2 minus x1. So notice that's what this is. We have one point and the other point. What we're doing is we're taking the second y, subtracting the first y. Taking the second x, subtracting the first x. That's what this formula does. It's just doing what I just figured out here to say, hey, it moves from 3 to 15 or 2 to negative 5. How far did it move? Right? This is just a mathematical way to write that down. Why is that important? Well, this is where we get point slope form from, just for the record, right here. We do a little algebra. What we do is I take both sides and I multiply them. By the way, this is m, right? Slope is the letter we use for m. Slope is, sorry, for slope is m. So I end up with this. The actual derivation, where does slope intercept, point slope form come from, is this. Okay, so I can take it and I can say, well, another way I could write this is, I could say, I can do it backwards. So y2 minus y1 I'm going to call slope m because that's what we always do. X2 minus x1. Formula. And what ends up happening is, just like if I had, oh, I don't know, there. If I had the 2, or no, I'll say x over 2 equals 10. What I could do is I could multiply this side by 2, and they cancel out. Then I have to multiply this side by 2 as well, and I get x equals 20. I'm going to do the same thing here, only I'm going to multiply both sides by this. Just like I multiplied by 2 here. I'm going to multiply by x2 minus x1. Now, one thing you'll notice, this subtext, that whenever the number is at the bottom here, if it was up, if it was y squared, that would mean y times itself. When the 2's down low like this, that means it's just the number of that, like the second y. And notice, this is the second y, and this is the first y that I listed. It doesn't really matter what order I list them in. This function, this formula works backwards as well. So if I accidentally switched these 2 points and I said 17 minus 3, or 3 minus 17 and 2 minus -5, it would still give me the same slope. Okay, but that's important to note. All right, so we got these guys. I'm going to multiply by x2 minus x1, and I get this. I get the left side, they disappear because they cancel out. I just left with y2 minus y1. And so it disappeared on the left side, but on the right side, I multiplied by that, just like I did here. I had to multiply by 2 times 10 and get 20. Well, now I have n times this whole thing. And that's actually what I write. I don't know what that makes. So I don't bother to write it out. That way I just write x 2 minus x. That right there, my friend, is point slope form. So we're going to use that form. We're going to learn ways that it's useful to us. Let's stop wasting time and get started on the actual lesson. Okay, but this right here, you're going to use this. So we're just using that, and here's the deal. This is the slope. Here's what we know about our line. M equals, oops. M equals slope. I don't really care what the name of the point is. It could be A or B or C, or not even have a letter name. Hard to remember what to type. Goes through the point with X and Y that are the first point. And it also goes through a point, another point. So all of these numbers are what plug in. There's 2 points that it goes through, and then there's the steepness of it. Okay. Now the cool thing is, it doesn't matter which 2 points I go through. So what tends to happen in this formula is actually we don't really care what the other point is, because if we know how steep it is, it'll go through that other point. So I've got my 1 point, and I don't need another one. And that right there is the finished formula. That's what it looks like in finished form. Okay. All right. Let's solve this problem. We're going to talk about echelons. This was the first problem that you had in the book entirely. So if you remember it, that's awesome. If you don't, then I don't blame you. But here's what it looks like. Let me push play. He needs how many tiles to make a 1 point? Let's go with I didn't even check. Let's see what it says. 1. Oh, this pond has 2 feet on each side. Okay, so it has 2 feet on each side, so I have to go 1, 2 in the corner, 1, 2 in the corner, 1, 2 in the corner, 1, 2 in the corner. That's going to be 3 times 4. That's going to be 12 tiles. Check. And you can go in here. This is something that you can do if you want. You can go into the actual assignment and do this. If we were live in class, we've been doing this from the beginning of the year. Oh my gosh, year 12. So that's what we're talking about. Okay. You can figure out the rest of them, but just for the record, there are 8 tiles to go around a 1 foot pond. 12 is what we just had for a 2-point pond, 2 foot pond, guided pond. And for this one, there are 16 tiles. Now, here's the interesting thing. We have the length of the side is 1, and there are 8 tiles. So what I'm thinking of is there's a point where it's 1 in length, 8 tiles. 12 in length. Sorry, 2 in length, 12 tiles. Those are the points we're using. We're keeping track of the 2 things that you can keep track of, which is how long are the sides, how many tiles do you need. Okay, so that's an important thing. Okay, look at that. We're going to actually walk our way through this. So we have our 1 foot in length, 8 tiles. 2 feet in length, 12 tiles. And 3 feet in length, 16 tiles. Okay, that whole thing be. Yep, I can. Okay. Okay, study the pattern in your table. What will continue? What pattern will continue? Well, this goes up by 1 every time. Hopefully that makes sense. This goes up by 4 every time. That's the slope. When the side length of the pond goes up by 1, it adds 4 tiles. Slope is 4. Important if we get there. Okay. I'll say X. All right, so there's that. How do you know the pattern in your table of that situation in the model by a linear function? Well, what do I notice? Does it always go up by 4 and that always goes up by 1? Yeah. Is this slope always going to be the same? Going up by 4 in the y and 1 in the x? Yeah. We are assuming that the pattern continues if the length number of cells 4. Forgot the. All right. In that case, the graph of this will always have slope of 4. It will never change in steepness, forming a straight line. Okay. That's why. Okay. Using what you know about the rate of change in the situation, write a linear function rule in slope-intercept form. Okay. Write a linear function in slope-intercept form from the relationship between the length of the side of the pond, S, and the number of tiles on the border, T. Okay. So this is a weird one because let's see. There's no y-intercept because in the past we've asked, well, what if you had 0 time? What if you had 0? What is the beginning? And this starts with 1 tile. So you might be tempted to say it starts at 8 and it goes up by 4s. But it doesn't start at 8 because this is not a 0. Remember, y-intercepts are where this equals 0. So if I go backwards and I find a place where this equals 0, well, this has to go up by 1. From 0 to 1. This would have to go up by 4 from something to 8, right? Which means this should start at 4. So I could, if I had a 0-sided pool, it should be 4 tiles, which doesn't make sense. You may notice that you're correct. It doesn't make sense because if you have a 0-sided pool, then it's, or a pool with 0 length sides, then it's not a pool, it doesn't exist. But there you go. So I know that side length, if we already found out that the slope is 4. We also know if we work backward, a side length of 0 gets 4 tiles. That's true. So we end up with this. I equals mx plus b. That's slope-intercept. That's what they're asking for. Well, I changed m to 4 and b to 4. I equals 4x plus 4. And I guarantee you, if you try to plug in the numbers up here, 1, 2, 3, and 4, 0, 1, 2, 3, 4, it'll give me these for x, or for y. All right, I'm going to stop for now. I'll be back. We are back. We just said the slope is 4. If we work backwards, the side lengths, we get tiles of 4, and blah, 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 blah. And then I was writing this in. I've already used this formula. I want to tell you what's going on, and then we're going to put it in a box over here. This right here is the slope formula. Okay, so really important. Slope formula. It is y2 minus y1 I'm typing this in a weird order because because that's the nature of typing math. It's really exciting stuff. Boy, are you lucky to be able to see what I'm doing. X2. All right. So I should be at x1, sorry. X1, y1, parentheses, and 2, comma, y2, parentheses. So that, because we're using parentheses already, and why use parentheses within parentheses? Okay, so slope between these 2 points. And I got to put up a line in there, and then I'm done. I'll circle it. Boom. Okay, so this right here is the slope formula, the slope formula. Okay, they talk about use the slope formula. This is what it looks like. It says if I subtract the y's, I subtract the x's, and I divide one by the other, I get slope. This is what we've already done, just so you understand. When I want to find how far it is from 1 to 2 or from 8 to 12, I think, what do I add to 1 to get 2? Or you can just subtract 1 from 2, and it'll tell you what you have to add to 1 to get 2. Same thing here. I ask, what do I add to 8 to get 12? 4. Or I could just subtract 8 from 12, and it'll tell me, oh yeah, you have to add 4 to get from 8 to 12. That's what subtraction is for. That's why it's called a difference, because it tells the difference, the distance between two numbers, okay? Okay, so what's going on down here is we have 212 and 316. Those are the 2 points right here. We chose to pick them. You could pick any 2 points. I could pick 1 and 2. I could pick 1 and 3. They'll all give me the same slope. That's why the slope formula is a useful thing. It works for any points on that line. Any 2 points you can pick. So it doesn't matter that I picked 212 and 316. I could pick any pair of points on that graph, on that table up there. All right, and what I did was I tabbed my y2 and my y1 and my x2 and my x1. I look at the first point I listed, and I call that point x1, y1, as in the first point. That's what this one stands for. It's not like multiplication or squared or anything. It's just saying, hey, these are the x and the y from the first point. And I have to plug them in, so I put the 2 for x1. I put the 12 in y1. Over here, I have my second point, and I plug in 3 for x2 and 16 for y2, and you can see that's what it looks like when I plug them all in. And I subtract 12 from 16 and 2 from 3, and I get 4 on top and 1 on bottom, or 4 divided by 1, which is 4. Hey, we just did that. We could do that really easily already just by going, hey, this goes up by 1s and that goes up by 4s. Yep. Slope formula is most of the time kind of a waste of energy and time. It's much easier just to understand what's going on and say, hey, the x changed by this much, the y changed by that much, make a fraction. But if you're slow, or if you're like out to lunch that day and you just can't think very well, you can always just use this formula because it always works as long as you do the math right. Okay, now, what is the format for point slope of a line? The format for point slope of a line is y2, or no, actually y minus y1 equals m times x minus x1. Notice now this one does not have a y1 and a y2 and all that. Now the y1 and the y2 are there, okay? But when we're writing a formula for a line, we leave one of them out. We don't need to have both those points. You can use both those points and figure out m. You could do that, but we're not going to do that right now. This is the official formula, and here's the things you need to know about this formula. M equals slope. And the line passes through x1, y1. Okay, so those are the two things I need to know. So these will all be, these will all be numbers. Number, number, and this will be a number. The first x's and y's are not numbers, okay? This right here, this x and that y, they're just x and y. They hang out there. Just like when you have point slope intercept form, you have y equals mx plus b. Okay, we're going to rearrange and simplify point slope form of the equation that you developed in question 5 to find slope intercept form. Okay, so we're going to take this, we're going to plug in the numbers. Are you ready? So I know what my slope is. Slope is 4. We just said that. I also know that it goes through, well, it doesn't really matter what point I pick. I'm going to pick the point 212, okay? Because I like those numbers. And it goes through that point. So we're going to say m equals 4. And I choose point 212 to be part of my. Why? Because it was up there. A 2-foot pool needs 12 tiles to go around it. That's what we learned earlier. Okay, so let's plug the parts in. Here's what it looks like. I end up with y minus 12, that's my y1, equals 4 times x minus 2. Boom, that's what it looks like. All right, and that's what we're going to use in the next chunk. That's point slope form. So let's do that. Now we're going to take that and we're going to deal with it a little bit more. Let me actually highlight it. Control C, and I won't have to print it again. Now it says rearrange and simplify this. This is point slope form. For the work that you developed in question 5 to find slope intercept form. So we found point slope form. It's right here. And we're going to turn it from one to the other. So what does that look like? Just so you understand what we're talking about. We understand that there's this guy. That guy should also be the same as y equals 4x plus 4. They are just different forms of the same data. Okay, so what does that mean? That means that I should be able to turn one into the other. I'm going to take and turn this guy into that using algebra. That's our goal here. I'm going to take this guy and I'm going to turn him into that. That's what they're asking me to do. We're going to rearrange it. And we're not going to rearrange it using some arbitrary rules. We're going to use the rules of algebra. Rules of algebra are what we call properties of equality. You can add both sides of an equation, multiply both sides of an equation, divide both sides of an equation by the same thing. So all those rules that you have learned, and we're going to practice more in later chapters. Okay, those are the official rules of algebra. And here's how it works. So the first thing I notice is I have a 4 outside of a parentheses, and I need to distribute it like this. So what I'm going to do is I'm going to go back in here. I'm going to write it. What happens if I distribute that 4? Well, I end up with y minus 12 on this side equals 4 times x is 4x. And 4 times 8, 4 times 2 is 8. And negative 2 is negative 8. Okay, so next, so my first step is I distribute it to 4. My next one is I'm going to subtract. I'm going to add 12 to both sides. Okay, so if I add 12 to both sides, what does that look like? On the end of y. Well, if I added 12 to that, it's just going to disappear. Y plus 12, y minus 12. If I do those both things to the y, all that's left is y. Okay. This y over, so I don't have to move the equal sign. Equals 4x. And I added 12 to this side as well. So negative 8 plus 12 is 4. Oh my gosh, I changed one to the other. Now is in intercept form. I turned the first one into the second one. I turned the left equation into the right one. That means that they're the same thing. I didn't add something to one side and not to the other, so I kept it equal. It should be the same equation. All right, that's the equation with the line. I'm going to do this one fast. We need to know the slope. I'm going to pause because my wife is singing.